in QGIS, we are already using the PDAL library for the data access to point clouds. But in fact, this is maybe just like 5% of what the library actually has to offer. It is, I would say, state-of-the-art open source library to deal with point clouds. It contains like dozens and dozens of filters that can do all sorts of things, from filtering data, classification, doing various export of derived data like the rasters or even meshes.
Welcome to another episode of the Mapscaping podcast. My name is Daniel and this is a podcast for the geospatial community. My guest on the show today is Martin Dobiasz. He is the CTO of Lutra Consulting, and today on the podcast we're talking about cloud optimized point cloud. Now, just a quick heads up, during the interview I used the abbreviation for cloud optimized point clouds, COP and COPC, interchangeably. This is a mistake. I understand if it's confusing, but just understand what I'm talking about is cloud optimized point clouds. And just before we get started, I also want to mention that this episode is sponsored by OpenCage. So OpenCage is a geocoding company and we're running a marketing experiment together. OpenCage has generously agreed to sponsor 4 episodes of this podcast, but instead of asking me to talk about them, what they've done is given away these sponsorship slots to projects that are built in, on, and around OpenStreetMap. And one of the winners of this sponsorship spot is a project called weeklyOSM. So you can find this at weeklyOSM.eu. And what is it? What is weeklyOSM? Well, it's basically an update of all the things that are happening in OpenStreetMap land. So if you go to weeklyOSM.eu, the first thing you'll see on the homepage is a bunch of interesting updates. So we've got mapping campaigns, we've got updates about different things that are happening within the OSM community itself. We've got events that are coming up, educational events, we've got demonstrations and tutorials, we've got people that are doing research based on OpenStreetMap. We've got updates about different software, programming languages, releases. It's basically everything you need to know or perhaps want to know about OpenStreetMap. So if this is something that you might be interested in, and it looks like a fantastic project, check out weeklyosm.eu. Again, there'll be a link to this in the show notes. Hi, Martin. Welcome to the podcast. You are the CTO of Lutra Consulting, and you guys do a ton of interesting work in the open source geospatial world. And today on the podcast, I want to talk about some of the work you've done around the cloud optimized point cloud, or COP. But before we get there, would you mind just introducing yourself to the audience, please, and perhaps letting us know how you got involved in geospatial?
Yeah, hi Daniel, thanks for having me here. So my background is in computer science, but I always liked hiking and maps in general. So over time, also within my father's small company, I helped him do some programming with GPS receivers and some stuff with smartphones. And yeah, that was around like 2005 when we did a small mobile application for smartphones that dealt with GPS. But then later on, during my university studies, I had a project where I just wanted to do something with maps. And my advisor pointed me to some very early version of QGIS. I think it was maybe 0.4 or so, and told me that, rather than doing some project from scratch, why not try to improve something there? So I tried, and it was fun. And since then I've been in geospatial doing some programming. And later, when I finished my university, I did some other jobs. But then since 2013, I have started working with Lutra Consulting, and there we do lots of geospatial stuff.
So just a quick question about your earlier work with QGIS. Was that back in the day when it was called Quantum GIS?
Exactly.
Wow. And we're talking about, when you say a project, are you talking about making a contribution to the open source code of Quantum GIS? Is that what you did? Or were you using it to do some processing as a step in your project?
Yeah, it was a kind of programming exercise. So typically, we would need to pick some kind of small project and implement it in some programming language. So this was, adding some new features to than quantum GIS.
Could you also tell us what that feature was that you added or improved?
Yeah, that's been a long time, but I think it was something like for the application to be able to accept command line arguments with like X and Y, minimum and maximum, so that when you open the application, it will be zoomed into this area.
Wow. Wow. When I think about the amount of functionality that's in QGIS now, it's hard to believe that things like that were missing back in the day. The promise at the start of this episode was that we're a discussion around cloud optimized point clouds. So when you hear the name cloud optimized point cloud or COP for short, obviously it's a point cloud that's optimized for the cloud. But I guess what I'm curious about, what does that mean? How is it optimized for the cloud?
So the optimization for the cloud is really mainly about the support of streaming. When we deal with point clouds, one important thing is that like these are typically really large data sets. So just to imagine like 1 kilometer squared can be easily many millions of points. And so the data set of a whole country, we are talking about trillions of points and many terabytes of data. So with this kind of size of data, it's clear that dealing with the whole data set, that would take really a load of bandwidth to download them and further process them. So the streaming is the great thing that you just download whatever you need from the data set and kind of skipping all the rest of the data. And this is what the cloud optimized point cloud format is all about.
Okay, so I know from previous discussions with people on this podcast around cloud optimized formats, if I think about cloud optimized GeoTiff, for example, the magical pieces for me for that is like the index within the cloud optimized GeoTiff, and I'm assuming there's something similar here in a cloud optimized point cloud. So an index internally in the file, and this idea of range requests. We've just been talking about streaming, so I wonder if we could start with range requests first. Could you first tell us what streaming means to you, and then perhaps explain how range requests make that possible?
Yeah, so streaming, as I think about it, is really like the concept of what people are used to about streaming of audio or streaming of video. Simply that out of one large file, you just want to skip to the piece of data that you are interested in and take that part and download just a small amount of data. This is where the so called range requests are very interesting. It's a feature of the HTTP protocol used on all the web servers, where if the web server supports it, you can simply tell that rather than giving me the whole file, please give me just some subset of the data starting at this point and being this many bytes long.
And of course, when we're talking about geospatial data, this range request can be a geospatial request. Like I'm interested in data within this bounding box. Is that correct?
Yeah, that's correct. So here is one of the complications that comes with geospatial data because we are dealing with 2D or 3D data, while typically with like audio or video streaming, it's really just like one stream in time. So this is something that needs to be addressed by some smart representation in the file.
Okay, perfect. So this brings us on to the next magical bit about these cloud optimized formats. And this is the indexing of the file itself. Go for it. It's all you. What do I mean when I say indexing of the file?
The indexing really means that to give some structure to the file. So imagine that like typical standards that are used for interchange of data with point clouds, like the LAS format or LAZ, you can think of them as that it's a one big bag of points. There is no way of telling like where you can find any particular point. You really may need to scan through the whole file in order to make sure that you have got to some area of interest that you were looking at. Now, with the indexing, things are different. We use a structure internally, which is called octree, and it's a three-dimensional structure. You can imagine it as a cube that has different levels. So at the root level of the cube, there is just one cube. Then in the next level, it will be split to 8 smaller cubes, and so on. So with every level, you get to having like a smaller cube with smaller amount of data, and this is what is really used as the organization of COPC. So in case the client, the user needs to access some small amount of data, we just go through this hierarchy and find the cube or multiple cubes that satisfy the request, and we can then only send some small amount of data instead of having to go through the whole file.
So when you're talking about these cubes in the Octree index here, are you just talking about an index map where I know, okay, this cube I have to get, or are you actually creating those cubes in the same way we might create overviews or tiles for large data sets and packing them into the file?
These cubes they are already like built into the file. So one part of the file is just the data itself, and the other part of the data is really the information about the hierarchy, like where to find, let's say, which cube.
If I had a LAS file, for example, and I converted that to a cloud optimized point cloud, because we're creating these cubes, this internal tiling, would I see a huge change in the size of the file once I converted that from a LAS to a cloud optimized point cloud?
If you worked with the compressed LAZ file, then yeah, you would see some slight increase of the size. But generally, I think we are talking about maybe 15 to 30% increase. But if you started with some uncompressed data file, then like the actual file size would be actually much smaller thanks to the compression.
Okay, so again, we've got these two really interesting things. We've got these range requests, which make it possible to stream data to say, I'm just interested in this chunk of data. And of course, we've got the indexing built into these files that we're talking about, these COPs, that allows us to just get that piece of data and take it out, and it's streamable. And I think for me, one of the magical things about these streamable file formats is that we need very little infrastructure to make it work. So my understanding is I could take that file, this COP, put it on a web server somewhere. If it had access to the outside world, I could take a HTTP link or a URL to that and put it in something like QGIS, and it would just work. And we don't need a geo server or a map server or a QGIS server or something like that in between that. Am I on the right track here, or am I missing something?
Exactly. That's the thing. It's really the beauty is there, like how easy it is then to host the data and get it to the users.
This removes the burden, or a lot of the burden, from the data host. They don't need to run this huge expensive server in the background just to serve out data. It is just, it could be blob storage somewhere, and that's it. That's all the infrastructure they need. I think it's absolutely brilliant.
Yeah, exactly. There is one more feature to all this that we haven't mentioned yet, and that's the backwards compatibility. So one important thing to note is that this cloud optimized point cloud is kind of just a LAZ file, which is already like a industry standard. So even if you convert your data to cloud optimized point clouds, you can still get loads of applications to work with this file. Just they wouldn't be able to use the extra features of the internal indexing, but it's still available, and it doesn't need like all the other applications to kind of implement special support for this format, which I find really great.
That is actually a really amazing thing. It kind of begs the question, like, why should we create LAS files then? Can you think of a specific use case where you would choose a LAS file over a cloud optimized point cloud?
There are still use cases also for the non-indexed LIS format, especially when you are preparing some point cloud analysis workflows where you maybe don't need the optimized access using the indexing if like you know that you will be processing all the points anyway and maybe in multiple stages. So in these cases, you can save some processing time when you simply do not do the indexing to cloud optimized point clouds.
Ah, okay. So you're saying that indexing might be adding this extra step, which is going to be destroyed when we carry on and do other forms of processing or filtering. So maybe during that processing chain, it makes no sense to add that extra work.
Yeah, exactly.
And so when I think about cloud optimized geotiffs, COGS, I think about GDAL. So my understanding is that GDAL has this functionality baked into it, and anything that uses GDAL can both read and write COGS. What is reading and writing cloud optimized point clouds?
Right now, it is possible to use PDAL to do the reading of COPC files, where you can also specify what is the spatial resolution and what is the area of interest that you want to work with. That's useful when you want to do some data analysis. Then QGIS has now support for loading cloud optimized point clouds. So you can use QGIS to load them and view those files. And there are also more and more projects coming to life that also support cloud optimized point clouds. I can think of a web viewer built by Hobu, where you can just point it to some existing URL, and within the web browser, it will do the visualization of the point cloud for you.
Wow. Yeah, I have to get that link off you and include it in the show notes. During a previous conversation, you showed me this in action. We had QGIS open. I think you dumped a point cloud in there of, I can't remember how many billions of points, but it was a lot. And what QGIS did was it took this LAS file and converted it to a COPC. It was unbelievable.
For this, we internally in QGIS use a small command line tool called Untwine, which was also built by Hobu. And so one can simply use this command line tool to convert any point cloud file to cloud optimized point cloud, or just by loading any point cloud file in QGIS. QGIS will do this automatically for you because again, QGIS, if it wants to show the point cloud data in 2D or 3D, it's just not possible to do it efficiently by having this unorganized data set. So it needs to do the indexing anyway. So we do the indexing to the cloud optimized point cloud. Another great thing about the cloud optimized point cloud file is that it actually includes everything that was in your original data set. So in theory, like you don't need to keep the original last file and the new cloud optimized point cloud file next to each other. You could, in theory, also delete the original file and you would not lose any data.
When you say everything that was in the original file, are we talking about like a classification, other sort of data attributes? What are you talking about?
Yeah, exactly. So generally, point clouds, apart from having the XYZ coordinates for each point, they typically also have some more attributes, and these are exactly the classification, intensity, number of returns, return number, and so on. Some software simply, when they process the data in order to be able to visualize the data, some of these gets completely ignored and this information gets lost. But not here. So all the information is preserved. And so the file is great for both viewing purposes, but also for analysis.
I want to talk a little bit about analysis in just a minute, specifically in QGIS. But before we get there, could you just explain the process to me, please, of reading like a file that's not on my local drive? How would I read a file in QGIS, a cloud optimized point cloud in QGIS from a link?
Mhm. You simply open QGIS, you open the data source manager, get to the tab where you deal with point clouds, and simply instead of pointing it to a local file, you switch to the mode where you set the URL of the cloud optimized point clouds on some web server, and that's it. QGIS will simply query the server, find out if it can deal with the range queries. And if it can, and if it's a valid cloud optimized point cloud file, it will simply start this streaming and it will load the data on demand. And of course, internally, QGIS will also do some caching of the data. So it's not that every time you refresh your view, it will need to go and fetch the data from the server again. And so the subsequent loads and views of the data will be faster.
So I'm pretty sure that cloud optimized geotiffs are read only. Is that also the case with cloud optimized point clouds?
Yeah, that's right. So you would use this for the read-only access.
So now that we have this cloud optimized point cloud format, and you've explained how we stream it, and I guess my question is, what did we do before we had this format? How did we stream point clouds?
Previously, there were already some existing formats that are good for streaming. So, from the open source world, one that was very interesting is, and is still very interesting, is the EPT format, which was also created by Hobu. And in a way, you can think of it as like raster tiles, but for point clouds, where you simply have a big directory structure with the individual files. So compared to that one, cloud optimized point cloud files have the advantage that it's not like, let's say, thousands or millions files in some folder structure, but it's just one single file. So it's much easier to deal with. Previously, also in QGIS, in our initial implementation, we relied on this EPT format, but now we have switched to the cloud optimized point clouds. And in the proprietary world, there are a couple of other formats. So, for example, there is the I3S format from Esri that supports point cloud and also other types of 3D data. And in the open source world, there is also the format called 3D tiles.
But I know that we can consume and create this format, cloud optimized point cloud in QGIS. Can I do the same thing in Esri, for example?
In Esri, I think the situation is a bit more difficult, as at some point they have created their own format for point cloud data. I think it's called ZLAS. So they didn't have support for the LAZ, the compressed version of LAS files, which cloud optimized point clouds is based on. So I'm not really sure if for example, Esri will be keen to implement this format, but let's see what future brings.
Whew, thank you very much. We've come a long way in the conversation already. Now it's time to turn to the analysis side of it. And I think we should stay with QGIS because Lutra Consulting has just finished a successful crowdfunding campaign to build a lot of extra functionality for cloud optimized point clouds in QGIS. So the question is, Martin, what are you going to build for us? What kind of functionality are we talking about? Or what is missing in QGIS today when we think about cloud optimized point clouds?
We are all very excited about this success. It's been a campaign that we have prepared together with Hobu and North Road companies. And yeah, so the problem in QGIS is that right now it can only visualize the point clouds. And of course, like you can do also the cross-section profile or do some measurements or some simple exporting of data. But for most of the people, point clouds are really more of like a raw data type, and they want to do further processing of the point clouds. So until now, there were some integrations of third-party tools, most of them proprietary, that would help people to do the analysis, do things like export point cloud data to raster digital elevation models and similar kinds of workflows. But now in QGIS, we are already using the PDAL library for the data access to point clouds. But in fact, this is maybe just like 5% of what the library actually has to offer. It is, I would say, state of the art open source library to deal with point clouds. It contains like dozens and dozens of filters that can do all sorts of things from filtering data, classification, doing various export of derived data like the rasters or even meshes. All this is there, and I would say relatively few people know about it because the PDAL library itself, it uses so-called pipelines, which are like small JSON files that you need to craft manually and then run to get some results, which works fine for, let's say, advanced users. But many ordinary users find this a bit too complicated. So this is what we would like to address, to take all the functionality that the PDAL library already offers, make it more, let's say, user friendly, and build a very simple integrated toolbox within QGIS. So in a future version of QGIS, when you open it, just like next to all the algorithms that you have for dealing with vectors and for rasters, you would have also the point cloud toolbox, where you could simply take your point cloud, maybe remove some noise, do classification, maybe do some spatial filtering, etc. All the workflow up to, let's say, creation of some raster digital elevation models or whatever you need. So this is our main focus for the campaign. There are a couple of other things we would like to improve. For example, to be able to work with large data sets of point clouds even in an easier way.
So, let's talk about that for a second, because I have a feeling that what you might be thinking about there or talking about there is creating these virtual files in the same way that we do with GDAL when we have a lot. Let's say we have a folder full of geotiffs, for example. You can create a virtual file and then pull from that entire data set. At least that's what I'm imagining that where you might be going with this. Am I on the right track?
Yeah, absolutely. So that's what we are really after, because point clouds typically are delivered in these tiles. These can be typically maybe 1 kilometer square tiles, which with dense point clouds is, let's say, reasonable size of a single file. And you can imagine that if you are working with a slightly larger area, you get to have hundreds or even thousands of these tile files. And by now, it has been a bit impractical to simply like load those files one by one to QGIS. It just doesn't work that well. Then everything gets slow and so on. But if you are able to kind of create this virtual point cloud that will be simply referenced from one single file, then the user experience can be much better for both the visualization within QGIS, but also for all the processing workflows that people may want to do.
So I just want to make sure I understand this. When we think about creating a virtual file, based on all these other separate files, which are themselves indexed, are we talking about creating an overarching index in the same way, the same kind of index that we may be created within the cloud optimized point cloud? Just an overarching one that covers all of the files. Is that what we're talking about?
Yeah, pretty much. Yeah, that's the main idea, to have this kind of meta hierarchy of the whole big data set.
How would that work if you were pulling from a URL?
It would work in a similar way that if you would give the client like QGIS just URL of the virtual point cloud file, it would download just that. It should be a small file that just references all the other files. And initially, the viewer could just simply show you the extents of individual tiles. And as soon as you get closer, then it will actually start to load the real data from the cloud optimized point clouds from the server.
If I had a list of all of the cloud optimized point clouds and their URLs, could I create that virtual file on my own machine and just have it sitting there and pull from that?
Yeah, that's something we would like to support as well. So we would like to have a combination of various options. So either there is a remote virtual point cloud that's referencing other remote cloud optimized files, or you have your local file that is referencing to remote files, or you could even have a local file referencing some other local files.
Do you think there's a world where this will be available through like a stack interface in the same way that the cloud optimized geotiff is or can be integrated into?
Absolutely. In a way, this is a similar concept that it is some kind of catalog of data. We've been even thinking about basing all this on top of Stack. So right now we see some technical difficulties in doing that, but maybe we will find a way around. So it's still an open topic. In any case, we would like to stay close to Stack. So maybe have some kind of feature like if you have a virtual point cloud, you should be able to very easily export the equivalent definition of it in Stack protocol.
And just for people that aren't familiar, what does stack stand for?
So Stack stands for the Spatial Temporal Asset Catalog, if I remember the name correctly. Yeah, it's simply a protocol for easy access to spatial and temporal data. So think of typically like satellite imagery, but it is being increasingly used also for distribution of point clouds.
And I think too, if you're listening to this and it's the first time you're hearing about Stack, it's well worth spending some time and finding out about it. I think it's a really promising idea. Can we copy paste the same thing and use it for other vector formats and just make every sort of vector format cloud optimized? And my guess is it works for points. Is there any reason why this wouldn't work for polygons or lines?
Yeah, so this is quite a hard topic actually. And nowadays, I think there are lots of discussions on like what would be the cloud optimized format for vectors. The fact that we need to deal with lines and polygons and all these things really complicates that. So I think there are a couple of formats that may end up being the cloud optimized vector, but it's actually much harder than with rasters or point clouds.
Is it to do with the indexing side of things? Like, do you cut lines in half? Do you cut polygons in half? Is that where the complication lies?
The complication is mainly with the structure of the geometry. So, for example, with point clouds, if you need to lower the spatial resolution, you just ignore some of the points and use a subset of that. But it's not very clear how to do that with lines or polygons. Like there are some, let's say, algorithms to do the generalization to, let's say, lower the number of vertices that would be used so that if you need lower spatial resolution, you can get that. But they all have some limitations. It really depends on the use case, like how exactly you would want this simplification to actually work. So it's tricky.
It sounds really tricky. When you think about some of these cloud optimized formats, if we just stick with rasters and point clouds for the time being, are people already talking about building extra features onto them? Like maybe being able to password protect them, for example. That might be a totally ridiculous idea. But my point is here, are people thinking about like what can we do next with this format? Or are we done? We're pretty happy with the way they are and like that problem is solved and now we're gonna deal with the functionality of how we can process them, how we can analyze this data in a client?
Hmm, that's a good question. And I'm sure there will be more and more developments when it comes to cloud optimized formats. People also come up with new ideas how to make things maybe even more optimized. But I'm expecting there will be a lot going on in this area, especially as you already mentioned with vectors, where right now we don't really have a good answer for them.
So we've talked a little bit about the successful crowdfunding campaign that you've run. and you talked about the kinds of amazing functionality you want to implement into QGIS. Can you give us a timeline for that? Like, when can people expect to see this in the next in a QGIS release?
So our plan right now is to deliver this new functionality in the following two QGIS releases. So that should be the QGIS 330 and 332. So one is coming out in February 2023, and the other one should be ready in June 2023. So within this, let's say, roughly half a year, we would like to deliver the promises of the new analytical tools in QGIS and virtual point cloud support and much more.
Wonderful. Well, I want to thank you very much in advance. I'm looking forward to seeing what people do with this functionality. So people will be sitting out there listening to this thinking, this is amazing. Where can I go to learn more? So I can include a link to Lutra Consulting. Is there anywhere else I should put a link to, like where people can go and find out more about cloud optimized point clouds or perhaps the work that you're doing?
Yeah, so you can find us on Twitter. That's our main social media where we publish what we are doing. I would also suggest to closely follow the Twitter of Howard Butler, who is the head of the Habu company, and to follow North Road as well, who is that are also doing the crowdfunding work with us.
Thank you very much for that. I'll definitely put links to those in the show notes of this episode. Martin, thanks very much. Really appreciate your time. Fascinating work that you're doing. I really appreciate it. Cheers.
Thank you, and thanks for inviting me to the podcast.
So once again, thank you very much to OpenCage Geocoder for giving away sponsorship spots on this episode, for giving me the opportunity to highlight some pretty awesome projects based on OpenStreetMap. And the project that we're highlighting in this episode is a project called weeklyOSM.eu. So this is worth checking out. If you want to know what's happening in OpenStreetMap, this is the place to go. Again, weeklyOSM.eu. I'll put a link to that in the show notes of this episode, and it's well worth checking out. I really hope you enjoyed that episode with Martin, CTO of Lutra Consulting. It's worth pointing out that we've published a few episodes now around this idea of cloud-native geospatial, and I will link to those in the show notes of this episode. Okay, that's it for me. That's it for this episode of the Mapscaping podcast. I'll be back again soon. I hope that you'll take the time to join me then. Bye.